Okay, in this video, we're going to look at projectiles at an angle. We started this story off already, and I want to highlight some of the things that are very important for this unit. And then on top of that, I want you to look at the steps that you need to take as a student learning projectiles. So, without further ado, let's get this thing started. I'm going to start off with the situation that we've done several times, and that's going to be with an object, in this case a ball, that's being thrown or kicked up at some particular angle and coming back down. And I'm going to also start off by labeling many of the attributes that you need to know. The first thing is our right triangle. That takes place. I'm going to actually do this differently. The other is our height. And then want to look at our total distance here. And just tag up a couple of things real quick. So this, going this way, is your velocity. This is Vy. This is Vx attribute. This along this way is dx. This along this way is dy. The top of this is known as the apex. Obviously, we have g that goes down, and that equals 9.8 meters per second squared, and that's always going downward. And then we have our time. And as we look at time, we have the time that it takes to come up, which is half time. Then we have the time that it takes to come back down. That's also our half time. And the entirety of it would be the full time. So on this side, I want to highlight two things and some steps that will help us out, and then I want to look at some equations that we need to look at. So the first thing I want to look at are some of the equations, and I'm going to put this by horizontal and vertical. On a horizontal, which means from left to right, going along that axis, which basically deals with the x, right? Some equations that we have is Vx equals dx over t. And we can rearrange this equation to solve for other things, right? Like dx equals, Vx times t. And also, to solve for time, equals dx over Vx. And that's our horizontal. The link between the horizontal and vertical is this right here. And I want you to understand that this right here, when we're talking about a projectile at an angle, this is the total time. And then we have our vertical. Our vertical goes up and down, and this is our y. And the equations we have for vertical, the first one is Vx, right? Or Vy, F, we want to call it a Vy. So it's the same as this one right here. And that equals g times t. And then we want to figure out dy, and that equals 1/2 gt squared. And we can figure out and solve for time in a couple of different ways, right? So you can go time equals the square root of 2 dy over g. And we can also say that time equals, by using the first equation, Vyf divided by g. Same thing here. These two equations for time will link the horizontal and vertical. Aside from that, the other things that you need to know is that you need to know the sine, cosine, tangent. I'm going to put those guys down here, in which sine theta equals your opposite over your hypotenuse. Cosine theta equals your adjacent over hypotenuse. And then your tangent theta equals your opposite over your adjacent. Okay, so then the next thing I want to look at is that I want to talk about some of the steps that you need in order to solve for these type of equations. So let's go look at some steps. So the first step that you're generally going to have to do with our basic is that you're going to have to complete your triangle. You're going to have to find the sides of your triangle. So you're going to have to find Vy and Vx. You're going to do that using sine, cosine, and tangent properties. Okay, that's the first thing I'll do. The next thing that you can easily do after that is find time. And in this case, it's going to be the half-time. And you use that generally by using the y equations, right? So after you figure out the Vy, you can easily go and use this equation here, T equals VYF divided by G is what I would use. And that's going to give you that half time. And then to get the full time, you need to multiply that by 2. Using the halftime, solve for dy. It's very important that we use the halftime. Then the fourth thing that you can figure out is that you can figure out the dx. Okay, and how do you do that? Is that you take, in order to figure that out, you're going to have to use your Vx and full time. And that equation that you're going to do, and going back to that, is going to be dx equals Vx times your time. And it's going to be time, it's going to be your full time. So to solve for dy, you're going to use that half equation. You remember for dy, that equation that you needed was dy equals 1/2 gt squared. Okay. Now I want to go through. So here's our steps. You're going to find Vy and find Vx using sine, cosine, tangent. You're going to find the halftime. Then if you multiply by 2, that's how you get your full time. Solve for dy. Use your halftime and solve for dy. And the reason why, because dy really only takes account the object either just falling or it just going up. Okay. And then dx uses the full time because I need to know the total time. Some things that you also need to know that are important is that Vy, okay, increases over time as it goes down. It decreases up. Okay. And it does this because of acceleration due to gravity. And that's basically G. The other thing that you need to know is that, so what I'm trying to say here is that along the Vy, it accelerates. The other thing that you know is Vx. Vx is constant velocity. That means that it has no acceleration horizontally. So once you release a ball, it doesn't get faster and faster and faster. Obviously, that wouldn't make any sense. Also, it really doesn't get slower, unless like wind blows hard on it. But remember, as we're doing this, we are neglecting air resistance. So we're not even considering air resistance inside of our functions that we're doing. Okay. So I want to take all this and I want to do an example problem and I want to be able to show you how we will calculate for these things. Okay. So I'm going to use the same situation that we had before. I'm going to start off with a line go across. I'm going to get me a ball, and that ball is going to be released, and it's going to come down. So the first thing I'm going to know is like, how was this ball released, right? If they told me that its initial velocity was, let's say, 5 meters per second, right? And they told me that it was kicked at an angle, all right, of, let's go make this angle 35 degrees. How can I figure out everything else? I'm going to go through my steps that we did before. The first thing is I'm going to do is that I'm going to figure out my triangle. So at my 35 degrees, the first thing I'm going to figure out is my Vx and my Vy properties. All right. So to figure out Vx, let's go do our Vy. Let's do Vy first. Vy, okay, that's going to be the sine property. So I'm going to go sine 35 degrees equals Vy over 5 meters per second. I'm going to multiply each side by 5 meters per second. That cancel that over here. So that means Vy equals 5 meters per second times sine 35 degrees. I'm going to put this on my calculator. 5 times sine 35, and that equals 2.87. The writing looks kind of funny, so let's look at these units better. Then I'm going to figure out Vx. That's going to be my cosine. And once I do the manipulation on that, you'll get basically the same thing. It'll be 5 times the cosine of 35. So Vx, if I go 5 cosine 35, that equals 4.09. 4.09 meters per second. So I have the answers for both of those guys. Let me set the Vy is equal to 2.87 meters per second. All right. So now I have those two guys. I can now figure out my Vy time, but I can do it a couple of different ways, but let's do it by using the equation we used earlier by saying Vy, okay, and that's going to be going back to my Vy equations, right, my vertical. VYF equals G times T. So Vy equals G times T. And I know what my Vy is because that's this right here. And I know that this is as well, so I need to solve for T. So T, if I rearrange that, equals Vy divided by G. So it's going to be equal to 2.87 meters per second divided by 9.8 meters per second squared. So I'm going to do that, 2.87 divided by 9.8, and that's going to be 0.29. So I'm going to round that out. I'm going to just leave it at 0.29. And understand this right here is my halftime because it's talking about the Y. So that means that my halftime equals 0.29. And now I can use that to figure out my height, right? My dy. So, and also I can just take that and multiply by 2 to figure out my full time. So my full time, let's multiply this by 2 in my calculator, is 0.59 rounded off. And the reason why we're using the halftime is because when we're doing this, it's simulating just like that building situation of an object falling down. And if it's falling down only, right, and reaching a velocity of 2.87 meters per second, that's what we're looking at, that situation, because it's the same time. My full time obviously is me multiplying it. So I'm going to find now the dy. To find the dy, I need my equation 1/2 gt squared. And remember me, I like dividing by 2. So I'm going to rearrange this equals my 9.8 meters per second squared times my halftime, which would be 0.29 seconds. And this square only goes for the 4.29 seconds. And that's going to be divided by 2. So I'm going to put that in my calculator. 9.8 times 0.29 squared. Then I'm going to take that and divide it by 2. And it's going to equal to equals 0.41 meters. So now I know that this right here is 0.41 meters. And now the last thing I need to figure out is my dx. How far across is it going? And remember that dx equals my vx. So going back to my equation, solving for dx equals vx times t. And that's going to be my total time, equals vx times t, and that's going to be my total time. And remember my vx, I solved by using my triangle, so about 4.09. So dx equals 4.09 meters per second, and my total time is 0.59. So now I got 4.09 times 0.59. Okay, so my dx, once I do this, equals 2.41, and that's going to be meters because that cancels out. 2.41 meters. So I now know that this right here is 2.41 meters. So that's where it's going to hit at. 2.41 meters is my dx. So if you look here overall, I did step by step for each of those things. To solve for everything, obviously, it takes some time. So, and that's the part that I think that you have to understand. It's going to take some time for you to solve for everything. And that's how these questions go. And it's a combination of a lot of different things. My advice for you is to be patient, to not avoid the work and actually do the work. And when you need help, go back to this video. Go back and see what did I do? How did I approach the problem? Right? And also, if you have any questions, you can always come and ask, and we can go from there. All right. Thank you, guys. I appreciate it. I'm going to stop this, and I'll see you in class.